The heat radiation by the natural convection is solved in this tutorial. A heat source is placed on a substrate and the substrate is placed in the air. The substrate VOL1 and the heat source VOL2 are created as solid body box, and the heat source is defined in the body attribute of VOL2. Natural convection is set on the model surface. As a result of the analysis, check the temperature distribution in a gradient contour diagram and in an overall view and a section view. A new project is created first. Create a new project. Click the File tab and select New Project. Set up the analysis space as follows. Set Model Unit Millimeter. Set Analysis Space 3D. Click OK button. The initial setting has been done. Two boxes for the substrate VOL1 and the heat source VOL2 are created. On the Model tab, click Solid and select Box Specify Length on the submenu. Designate the start point. In the Parameter Input dialog box, enter starting point x -25, y -25, z -1, and click Next button. Set the width. Enter width of 50 and click Next button. Set the depth. Enter depth 50 and click Next button. Set the height. In the Parameter Input dialog box, enter height 2 and click Complete button. Click Exit button in the Parameter Input dialog box and exit. The box for the substrate VOL1 has been created. Create another box. On the Model tab, click Solid and select Box Specify Length on the submenu. In the Parameter Input dialog box, enter starting point x -10, y -10, z1, and click Next button. Set the width. Enter width 20 and click Next button. Set the depth. Enter depth 20 and click Next button. Set the height. In the Parameter Input dialog box, enter height 2 and click Complete button. Click Exit button and exit from the dialog box. The box for the heat source VOL2 has been created. We set the analysis conditions. On the Model tab, click Analysis Condition. The Analysis Condition Setting dialog will show up. Select Thermal Analysis What on the Solver tab. Click the Thermal Analysis tab. Confirm that analysis type is set to steady state analysis and ambient temperature is set to 25 deg. Then, click OK button. The analysis conditions have been set. We set the body attributes and the material properties. Highlight the substrate on the modeling window and click to select. On the right-click menu, click Body Attribute/Material Property. In the Body Attribute/Material Property Setting dialog box, enter Body Attribute Name VOL1. Select 03_resin on Material DB and select 006_ glass epoxy. Then click OK button. Click on the heat source on the modeling window. On the right-click menu, click Body Attribute/Material Property. In the Body Attribute/Material Property Setting dialog box, enter Body Attribute Name VOL2. Select 04_ dielectric material on Material DB and select 001_ alumina. Then click Edit Data button at the side of Body Attribute Name. In the Edit Body Attribute VOL2 dialog box, go to the Heat Quantity tab and enter heat quantity 1 watt. Click OK button. Then click OK button in the Body Attribute/Material Property Setting dialog box and exit. The body attributes and the material properties have been set. We set the boundary conditions. In the Analysis group of the Model tab, click Outer Boundary Condition. In the Edit Boundary Condition dialog box, set as follows. On the Thermal tab, select Boundary Condition Type, Heat Transfer, Convection. Confirm that natural convection, automatic coefficient calculation, is selected. Confirm that room, ambient, temperature, use ambient temperature of the analysis condition, 25.0 deg, is set. Click OK button. The boundary conditions have been set. Now, set the mesh size and run the solver. Set the mesh size. In the Analysis group of the Model tab, click Analysis Condition. The Analysis Condition Setting dialog box will show up. Click the Mesh tab. Deselect Set the General Mesh Size automatically. Enter 2.5 in General Mesh Size. Click OK button. On the Model tab, click Run Mesher/Solver. The calculation will start. The calculation finished dialog box will show up when the calculation finishes. Select both Show Field and Show Table. And click Show button. The table will show up. The calculation results are available in various formats. Check the calculated values. The temperature, maximum, minimum, average, and heat quantity are shown in the table. Closing the table, the screen will change to Results window, and the meshing result will show up. Next, let's take a look at the temperature by gradation contour and at the cross-section. In the Display group of the Results tab, click Gradation Contour. The gradation contour diagram of the temperature will show up. Let's take a look at the results at the cross-section. In the Display group of the Results tab, click Show Cross-Section. The cross-section dialog box will show up. In the Cross-Section dialog box, select Simple Mode. Click YZ Plane. Click Create button and Close button in order. The cross-section will show up. Finally, save the project. Click the File tab and select Save Project As. Enter the file name and the location in the Save Project As dialog box and save it. Saving allows you to launch Femtet at a later date, open the project, and review the model and analysis results. That's it for the heat transfer analysis tutorial video. See the tutorial topics in the Femtet help for more information. Thank you for watching until the end.